When you're dealing with factors and multiples, your first step is to often break numbers down into their prime factorization, meaning you divide them by numbers until they can't be divided evenly anymore. For example, I could take the number 54, and I know that breaks down to 6 times 9. And then 6 can break down to 2 times 3, and then 9 can break down to 3 times 3. So the prime factorization of 54 is 2 times 3 times 3 times 3, or 2 times 3 cubed. For larger numbers, you can follow the same steps, but since you're likely to not recognize all of the factors, you can just take the number apart a piece at a time. So I can see that 660 ends in a 0. So I know it's divisible by 10. So I can break that down to 66 times 10. And then I can see 66 breaks down to 6 times 11. And then 6 breaks down to 2 times 3. And 10 breaks down to 2 times 5. So the prime factorization of 660 is, I have a 2 and a 2, so 2 squared, and then a 3 and a 5 and an 11. In both of these processes, we ended up with the prime factorization, meaning we divided and divided until all we had was prime numbers. So while the yellow highlighted numbers are prime numbers, these blue highlighted numbers are simply known as factors, meaning they divide evenly into the original number even though they themselves are not prime. So sometimes you may want to know all of the factors, not just the prime factorization. But to find all the factors, your first step is to break the number down to the prime factors. So in this case, I can take 68, and since it's even, I can divide it by 2, and I get 2 times 34. 34 is even, so I can break that down to 2 times 17. And 17 is prime, so at that point I can stop. So the prime factorization is 2 times 2 times 17. So to find all of my factors, I can simply take my prime factors and mix and match them as I multiply them together. So I could take 2 just by itself, and that's a factor, or I could take the 2 and multiply it by another 2, that gives me a 4, so that's a factor, or I could take a 2 and multiply it by a 17, which gives me 34. Or I can multiply everything together and I get 2 times 2 times 17, and I get 68. So 2, 4, 34, 68 are all of the factors of 68, while 2 and 17 are simply the prime factors. Oops, and it looks like I should have added 17 to my list, but you get the idea. So once we know how to fully factor different numbers, we have to address the issue of something called your greatest common factor and your least common multiple. Your greatest common factor and your least common multiple are just two ways of comparing the prime factorization of any two numbers. So to illustrate how this works and the difference between greatest common factor and least common multiple, we first start off with breaking our numbers down into their prime factorization. So 68, we know that breaks down to 2 times 2 times 17. I don't know the prime factorization of 72 yet, but I can start by breaking that down to 8 times 9, which I can then break down to 4 times 2 and 3 times 3. And the 4 I can break down once again into 2 times 2. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. The greatest common factor is the largest number that would divide evenly into both 68 and 72. And to identify the greatest common factor, all I do is count the prime factors each number have in common. So I can see that 68 has 2 2's, and 72 also has 2 2's. And that's it. 68 has a 17, but 72 does not, and 72 has 2 3's, but 68 does not. So my greatest common factor is just the two factors they have in common, or in this case, 2 times 2, or 4. The least common multiple, in some ways, is the polar opposite of the greatest common factor. Instead of looking for the largest number I can make, I'm looking for the smallest number I can make. I'm looking for the smallest number that both 68 and 72 will multiply up to. So to figure out the least common multiple, I simply make a list of the prime factors I would need to build both numbers. So to build 68, I would need a 2 and a 2 and a 17. To build 72, I need 3 2s, but since I already have 2 2s from 68, I only need one more 2. And then I need 2 3s, and I didn't get any 3s from 68, so I have to add them to my list. And that looks like a pretty big, scary number, and I'd have to have a calculator to figure it out. But in this case, the least common multiple of 68 and 72 is whatever 2 times 2 times 17 times 2 times 3 times 3 is, or 2 cubed times 3 squared times 17. That's the smallest number you can multiply both 68 and 72 up to. In other words, this number, whatever it is going to be equal to 68 times 9, and it's also going to be equal to 72 times 17. We can find the greatest common factor and least common multiple of numbers with variables as well. And my first step, as before, is to break everything down into prime numbers. So 30 I'm going to break down to 3 times 10, and 10 breaks down to 2 times 5, and then my y cubed breaks down to y times y times y. Or my prime factorization is 2 times 3 times 5 times y times y times y. For 20, I use the exact same process. 20 breaks down to 2 times 10, which breaks down to 2 times 5, and then my y squared is simply y times y, so my prime factorization is 2 times 2 times 5 times y times y. To find my greatest common factor, I'm first going to identify the prime factors that both numbers have in common. So we both have a 2, and we both have a 5, and then each number also has 2 y's. So my greatest common factor is 2 times 5 times y, or 10y squared. To find my least common multiple, I'm simply going to count the number of individual prime numbers and prime variables that I would need to build both numbers. So to build 20y squared, I would need a y and a 5 and a 2 and a 2. To build 30y cubed, I'll need a 2, but I already have one from my 20y squared, so I don't need an extra one. I will need a 3. I already have a 5, and I already have 2 y's. So really all I need as my extra parts to build 30y cubed is my 3 and my y. So my least common multiple will be a 2 and a 2, and then a 3, and a 5, and then 3 y's. And then from that set, I could either make 20y squared, and I could also make 30y cubed. Or my least common multiple is 60y cubed.